So, can you hear me? Is it great? Okay, great. So, thanks a lot for being here, first of all. This is going to be a very weird talk, probably, I don't know, because I'm going to talk about a few things that I do in my life that I've done. So I don't know how much it fits into the Jfokus schedule, but I hope you will enjoy it, because I'm going to talk about, well, Hello World is the song that you heard this morning, if you were that at the opening. I'm talking about the universe. It's the thing I was working on as a PhD student and a postdoc. And then Uranus is more related to my music career as a comedian music career, so to say. So let me start. I will start with this is a little bit the outline of what I'm going to talk about. So the universe and its cosmological simulations, in the sense that this is how I started my career, so to say, in the tech world, because when you run cosmological simulation, when you run simulation of the universe, you need to basically do high performance programming. So I got a lot of interest into high performance programming, into C, C++, MPI protocols, and so on. And I worked in the field for more than 10 years, so it's a big thing. It's a big chunk of my life. And then I moved to the industry to work for a private company. And the world, in the sense, I'm doing Earth observations now, and doing also machine learning applied to Earth observation. Not only that, but that's my main focus. So that's sort of the Earth, the world. But then, in parallel to these careers that I pursue in a sort of serious way, I'm doing something which is even more serious for me, but it's comedy stuff, so it's a parody thing, but for me it's a very important thing. It's a very serious part of my life, and it's related to this Uranus and Hello World. Uranus, of course, it's absolutely, you don't have to think about anything weird when you think about the world. It's only about the planet, of course, but it's so I'm gonna talk about this well, dead jokes, whatever, and music programming, and how that's mingled with my music career, how these things ended up from astronomy and programming to well, music. So let me start with a few words. This is a nice picture of the universe. It's a bit old, but that's the idea. I mean, that's the picture that we have in mind when we think about the universe. So that was the thing that captured my attention, so to say. When I was at high school, I decided to study physics and do astrophysics, because I sort of wanted to understand how everything came into being. So this is the standard picture, more or less, that we believe is the closest one to reality. So there's everything starting from a big bang here. There are quantum fluctuations, the universe starts expanding, and then you have the formation of galaxies, stars, planets, and so on and so forth. And so here on the x-axis you see the time, and every slice here is basically a two-dimensional projection of what the universe is at different points in time. So it starts like this, and then it ends up like this, and this is the old WMAP satellite that ended operations already since quite a bit, but it's still a nice picture to have in mind. And so this is what I was studying. I was studying the evolution of the universe. So the evolution of the universe is something that spans through very different scales. So it goes from the Earth down to the observable universe, which is various billions of light years wide, if not more. But the idea is that you want to simulate this everything, basically, and you want to connect these different scales all together, right? So there's the Earth. Then the Earth is part of the solar system. The solar system is part of the solar interstellar neighborhood, and the Milky Way galaxy. You know, the stars here are located in this spiral arm of the Milky Way galaxy. The Milky Way galaxy itself is a part of another group. It's called the local galactic group. So again, everything belongs to a larger structure. Everything is intertwined, and a large part of what I've been studying were the interactions. So how the environment, so how the fact that the Milky Way is located within this local galactic group, which is located within this Virgo supercluster, which is located in this system of local supercluster, which you see here. Every point here is, so every image here is basically another point in this other image, and so on and so forth. So you can have an idea of the scales that are at play here. And so when you want to simulate, so when you want to sort of reconstruct the whole history of the universe, and span through very different scales. Usually you don't really simulate the Earth by itself, you simulate by, you have a much wider resolution, but the idea is still that you want to have a computer model of what happens from the beginning to the end. And this is sort of what you do. So you take a box, you put a bunch of particles, say each particle is like proxy, it's like a tracer for gas or other kinds of matter that populate the universe. And then you start from the very, Z is here is a variable, it's called redshift, and it's basically just another way of measuring time. And then when you move on, you take these particles and you start seeing how they condense. You see here, you see this over densities here. So every box contains these particles, and the particles tend to get denser and denser and form these filaments, these knots here, these huge parts where clusters of galaxies might form. So where you see all these galaxies clumped together, and until we get to redshift 0, which is nowadays, and you get a picture of what the universe today looks like. So this is more or less the idea. You want to do this kind of simulations. Of course, you need to have billions and billions of particles. You have billions and billions of stars and billions of galaxies and so on and so forth. And so the thing is that this needs really efficient computing, scalable solution for you being able to run these programs on very large, high-performance clusters. And usually, yeah, this is how I got to programming, basically. So in C, C++, use a lot of MPI, so multitasking programming, sometimes combined with multi-threading and so on and so forth. So that's sort of where my roots in the programming world lie. Just to show you something, this is a cool picture. Again, it's from few years ago, but this is how you can, you see the left side, these are real observation of the universe. And there's a simulation from many years. I think now they're gonna better. I just left the field, so I don't know what's the state of the art. It was the state of the art like 6-7 years ago, illustrious simulation. And you see that this is what you simulate in a computer and really looks like what you actually see in the real world. So, and the difference here is that you are, to get to this picture, you can get in your computer slices of the universe, snapshots of the universe from the start. So every moment in time you have a picture, so you can sort of you have an image on how the universe was in the past in order to look it like it does nowadays. And it's pretty good because you can do a lot of studies, you can do a lot of predictions on if you want to do kind of weird observation and try to find phenomena that are linked from the universe today to the universe in the past and how this history are intertwined. So this is sort of the whole idea. But at some point, this looks maybe like a nice thing to study, a nice thing to do, but I got bored, so I started switching from cosmology to machine learning. That's how I got interested. We published a paper with my former co-authors from the University of Jerusalem and Potsdam, where I used to do my postdocs. I did 2 postdocs in these universities. And we did some very basic machine learning algorithms, so with gradient boosted decision trees to extrapolate. So using these simulations, we were studying, since in a simulation, of course, you have all the variables. Of course, if you have a simulated galaxy, you know everything about it because it's in your computer. And so you can study this and try to see which features of these galaxies are then observable in the real universe. And so you take observations, of course, are incomplete and they're missing and there are mistakes and everything. And so you can sort of tune your machine learning algorithms to the features that you can actually observe to predict other properties of the galaxies. I don't know if it's clear. I think it's a cool idea. So this is like to bridge, again, the sort of to interpolate when you have missing data in observations. You can extrapolate with machine learning with the help of algorithms that are trained on simulated data. And this was sort of my first step into machine learning. And then at some point, I decided I wanted to move back to my country, Italy. I left academia and I started working in a private company. And I started working with observations that are now done when satellites is pointing in the wrong direction. So you have a satellite in space, it's not looking towards the star, which is where it should look, but it looks towards the Earth. So what happens when satellites start taking pictures of the Earth? And you want to study the surface of the Earth, you want to study maybe climate, you want to study the environment, or any other kind of phenomena. So this is what I started doing again as in my career in TopNetwork, which is the company where I'm working at the moment. I'm doing analysis of satellite imagery of the Earth. So again, for me as an astrophysicist, this is still the wrong thing to do, but you know, I'm getting paid for that, so it's all right. Fair enough. What do these satellites do? There's many kinds of missions. I'm focusing now, just to make things short, I'll talk about the so-called multispectral imagery missions. In particular, there's the Sentinel missions of the ESA, the European Space Agency, that provide free data. They are freely accessible, they are open, everyone can use them. There's historical data sets of this data starting from 2016, I guess, and they cover the whole planet every 5 days. So you have pictures of the planet every 5 days taken at the same time, same location. If you want to monitor something, it's very useful because you don't need to send people, for example, in the Amazon, so you don't need to send people in the desert. You can see what happens there every 5 days and update the image. And that's pretty cool. What is a multispectral image? It's an image where you don't just take pictures of what you can see with your eyes. So this is the visible part of the spectrum, but you take pictures. So this is the electromagnetic spectrum at different wavelengths. This is like the part that you see with your eyes. It's the blue, green, and red, so the usual RGB scheme. You can take pictures of the Earth, though at frequencies are not visible by the eye, and that's cool because then you can monitor, you can see things that you wouldn't otherwise see. You can take pictures, so in the near infrared, shortwave infrared, and so on and so forth. The problem of these pictures, of course, is that if there are clouds in between, or there is some kind of turbulence, then nothing. You're screwed. It's your image is not worth. So the upside is though that there is a reasonably frequent picture taken by this satellite. So there are some areas that are reasonably well covered if it's not too cloudy or too rainy. And so this is just to give an example. This is just the raw file. If you get like of the area around Rome, this is the RGB without corrections. It's just the data that you can download. Then of course you can enhance and make a nicer RGB picture if you want. And this is sort of the one-dimensional scheme, so the black and white representation of the data in the near infrared. So this is what you see in the near infrared. And there's a bunch of cool things you can do. I'll just mention one, which is for me is one of the nicest applications because it's very easy. So it turns out here you can see from these graphs that the wavelength, so the electromagnetic waves that are reflected at the surface of the Earth have a very strong absorption around the chlorophyll. Here you see like there's this peak, which means that you can construct an index. So around this value, basically if you subtract the value at the near infrared minus the value at the red, you get an index, a number that is very sensitive to the presence of chlorophyll. So basically, from space you can see you can monitor the health of plants, and this is called the normalized difference vegetation index. It's a very easy thing. I mean, you see here there is some correlation between the presence of chlorophyll and this NDVI, and the cool thing is you can make pictures like this. You can find different ranges, and at different ranges you can identify different kind of structures. And this is just taking, you just take the raw pictures, you do this algebraic operation on the different layers of the image that you get, and you get these nice pictures. Like here you can see there's a barren land. You can identify some kind of buildings. You can identify with different shades of green if there's trees or other kinds of vegetation. This is just an example, but there's a lot of work you can do. Then you can make better, you can improve this if you want to add some deep learning. So something that we developed with my company, where some deep learning algorithms, so UNets for segmentation. So if you want to make some kind of more precise and more flexible algorithm to analyze these images, you can segment them. So you have some training data. You need to feed the net with some target and a target mask for the training data, so which are patches of the images of the surface of the Earth, and then you can reconstruct the presence using the presence of different kinds of land. So, for example, green here is fields, the red one is the buildings, and the yellow one is barren land. You can reconstruct it using this kind of units. So this is how I got sort of into deep learning, developing these kinds of algorithms. Let me just talk a little bit more about things that we are doing, which I find pretty cool. It's this daily fire hazard index. So basically, once I mean, I don't know how much this is probably not a big problem for Sweden, but wildfires are a huge problem in Sicily, in the southern parts of Italy, of course, because it's pretty dry and there's a lot of wind. There's a lot of there's not so much moisture, and weather tends to get very warm in the summer. So there's a lot of areas that are at risk. So we took some works in the literature and implemented them into a software that we are working now with some Italian public agencies to make this available for them. And what we are doing basically is using this satellite imagery to monitor the status of the vegetation, which you can do with some formulas. And so once you know the level of dryness, the level of moisture, the level of presence of dry vegetation in a certain area, you also know if there is some kind of potential for fuel for fire ignition, which is danger. And there are some formulas here. I'm just showing something just for showing you that we have some mathematical, very basic mathematical background to implement all of this stuff. And so we combine this data with meteorological data we get from some external service, from some API, and so every 5 days we can update the status of the vegetation, and then combining this, we can get sort of near real-time information about the potential for fires. And so these are the kinds of map that we can produce. Like this is for Sardinia, for the Sardinian island in Italy. So we have risk maps of this kind that we produce. And again, this is also, we have also some kind of, I mean, there is also a machine learning part into this, because we studied, we trained the algorithms on the historical series, where we know that when there was a fire, so we can take the historical part of the from the satellite database and see if there is some signature in the previous images that then is like some kind of proxy for an upcoming wildfire in some region. Of course, combining that with the meteorological data. So that said, let's come to the fun part of the talk. I hope I wasn't too boring for this part. The next one will be mostly music. So anyway, what about Uranus, HelloWorld, and so on and so forth? Now, I told you I'm working also with Nanowar Of Steel. It's I don't know if someone of you knows the band, but we have been active for 20 years now. This is me and my nice bass with these very nice orange strings. We played a lot of shows, I don't know, like on average maybe 50, 60, 70 per year everywhere. We've been twice on tour in the US. We have million views and all these nice numbers that I need to show just to show off that we are actually a not so mediocre band. We can do better, but still, it's pretty nice what we achieved. So actually 1.5 years ago, we celebrated our 20 years in Milan. We did this show, sold out show. Yeah, one of the best shows ever. So it will be available online soon. Yeah, that's me without with my natural hair. This is probably my natural hair more than my actual. But let's talk about Uranus. So I told you I was talking just about astronomy with 2S, and these are some pictures that we took when we went to shoot this video. It was 2020, so it was during the pandemic. It was a little bit of a mess to shoot it, but we managed it. This is a nice observatory in Italy. We went there. I had connection through my old colleagues in the astrophysics field, and so they let us film inside the observatory, but at some point they found out what the song was all about. They were not so happy about it. we were risking, because I sent them the lyrics, and I thought they would understand the joke. I didn't really explicitly say what Uranus is all about, because I took for granted that people could speak English in a scientific institution. But when they did understand, and they were a little bit upset. We had to find some compromise. So if you go, there's a nice thing. If you go on the website, if you go on the video and you check it, it's gonna be written that this was filmed in Switzerland. It was not. It's just that we had to buy some stock images from I forgot from which side, but we had to buy like some drone imagery of an observatory which looked like this one, because this one has two domes. And so we found one that looked like, from the outside, looked like this one that had two domes, and it was in Switzerland. So we bought the image and we said, okay, we'll just say it's in Switzerland, so we don't get issues with the with the Italian one. But they complained a little bit. It was a little bit of a fight, and we had to invest a lot of money on that, because we had to move to the observatory, the whole crew. We had the dancers coming, we had all the costumes and the production. Plus there was COVID, so we had all these COVID protocols things that in Italy was completely crazy. So we had to do like checks and everything. It was a nightmare, but we managed to do that. So I'm pretty proud of the video. So I will show you a part of it. I hope you can listen to the music.
I like it big, I like it cold, I like it blue, I like it both. I like it with the 2% of methane. I want it icy, I want it large, want it spicy with electric charge. Fluid outside and rocket inside.
Well, so thanks a lot. No, I hope you understand the irony more than Italians, which is weird, but it's good. Who would say that? It's probably language barrier that we had in our own homeland, whatever. So this is the main thing, though. I think that brought me here. Hello World. So again, I would like to thank Matthias for inviting me, because we had this song that came out. We published it on the 4th of December, and we wanted to make, as I mentioned, our guitar player. He's a full-time. He's actually like now a CTO of in a company. So he used to be a developer. Now he's high in the ranks, but still he grew up with Java, and so he's the main composer of the song. This is the GitHub repository. We wanted to write a song that was just source code. So we wanted to make an executable song or something like with no lyrics, just source code. And it's there is no, I mean, the first thing that people ask us if, oh, you did it with Suno or some other AI system. We actually didn't, but because the song was written like 4 years ago, we recorded it during the sessions of our latest album. We didn't publish in that album, and we just kept it for the future. We said, okay, let's just record a bunch of songs more, and then we released it as a bonus track in December. So the idea again is just that, I mean, you've seen the video this morning, but the idea is that we wanted to make a full GitHub repository with the code. Now we got 1,700 stars for the dumbest code ever written. I guess it's just hello world, which is uselessly complicated, because there's all the kind of classes and everything that's been built on top of it that's completely redundant. But it was a success. Like I think it was like around 2 million views on Instagram. It's close to 1 million on YouTube, so it was a huge success. And by the way, like this thing got usually metal bands, music bands get endorsed by, I don't know, by music instrument firms like I don't know, Fender, or usually I'm endorsed by Marshall or something. We are endorsed now by JetBrains. I can tell you from tomorrow. So tomorrow we will make our first release with JetBrains endorsement. You will see a preview now of this, because they contacted us. Okay, they told us your song is so great. They gave us access to all their products. They got a lot of free codes. For me, it was a blessing, because I mean, I'm a Vim guy. I used to do everything from the command lines and just 100%. I never used an IDE. I mean, I used an IDE, but not so. I wasn't very happy about it. Now I had I mean, I switched to PyCharm, and I'm using the AI assistant and everything that they provided me for free, thanks to them. So I got more productive. I mean, it was a. Sorry. Yeah, exactly. No, there's the Vim. Yeah, there are Vim bindings inside the for the PyCharm that I'm using. So it's great for me because and then I can just add the from with a couple of strokes you can add the AI comments on everything. I hate using the mouse. I guess like every real developer should hate using that. I don't know. So that was why. But I got really. So it was a smooth transition for that. But again, so we got endorsed by JetBrains. And we got all the licenses for free, and we are very happy about it. So we made an upgrade to the song, because if you remember this morning, the songs ends up with a null pointer exception, which is it's a very sad thing, because you cannot really run your program safely. And so we teamed up with JetBrains and we made a patch of the song. We corrected the code. Yeah, so we are going to release the patch tomorrow. The official video will be online, but you will see it now. So again, this is like it's a very, very tough thing. Now, please let me have your attention, because we are changing this variable from false to true. So metal won't be false anymore. We found out, thanks to IntelliJ idea, that if we set this to true, then we don't call this null string, we don't call this method on a null string, and we don't end up with a null pointer exception. It was very deep. Without IntelliJ, we would never have figured out. So it was really. Thanks to their endorsement, now our music can go on. So we released the song with a different ending. It's an ending that actually compiles and runs smoothly to the end. But I will show you just a video of the patch that we made in collaboration with JetBrains. So this is the null pointer exception. Unfortunate thing. It would not be doable without this. Come on.
Green table 0, I less than 4, I plus plus. System out of green element. Hello world. Semicolon. System out of green element. Hello world. Semicolon. Hello world. Semicolon. Hello world. Hello world. Hello world. Hello world. Program finished.
Huge success thanks to the IntelliJ idea. It was really helpful. Otherwise, we would not have made it. So thanks to them, now we will have a running version of the song. It will be up. Tomorrow will be the video, and then I think in the next few days, it takes a while for the digital service providers, so like Spotify's and everything, to get it online. But it will be, so there will be another version, a proper version of the song. But we are in Sweden. I'm in Sweden, so I don't come here that often. But with Nanowar of Steel, we have some kind of relationship with this country. So there's two main things that I wanted to show you before I leave the stage that relate us to Sweden. And the first one, I was mentioning it today, is Valhallelujah. Is our IKEA praising song. We wrote a song. We thought that Odin nowadays would not be going around killing people anymore, but it would be rather building furniture. And so we wrote a song about worshipping Odin in a proper way. And this is just an excerpt of the song. It's one of our most viewed videos on YouTube, so I hope you like it. So now I think we became the biggest contributors to IKEA worldwide, because every show that we perform, we build on stage a luck table and then we throw it on the public. And it's a true thing that we do most of the time. Sometimes, especially in Germany, they don't let us do it because on safety grounds. But we did it. Yeah, we do it almost every. And so people destroy it or jump on it, and so we buy, I don't know, maybe 40, 50 IKEA Lex tables per year. So it's a sizable chunk of their production, I guess, in Italy. And the next thing is just to end up. This is probably know this guy, Joachim Broden of Sabaton. Pretty known band from here, and so we had the honor of having him on a song. If you don't know Sabaton, they usually sing about war songs. We thought that the biggest war that Italians fight was football matches, because we are more excited about that than actual wars. And that was when we were defeated in Brazil against Brazil in 1994 in the US. I think you should remember that, because Sweden, I guess, got to the final stages of that World Championship. I think was third or fourth, right? So it was memorable for you as well, but for better reasons probably than us. So I'll just show you a clip from this.
11 soldiers marching under the sun on fields of green. Is their last battle, death or victory? Against the odds and all the bets, bookmakers say there is no chance. Cariocas win numbers 2-1. And Captain Baresi lives bravely the last line of defense. Immortal! While Roberto Baggio is ready to fire on top forever. Pasadena 1994, let's fight for the heroes sent to war. Pasadena 1994, for the glory. Pasadena 1994, first stuff is over and the score. Pasadena 1994, for the FIFA World Cup.
So, and that's the final things. Have a little bit of shameless promotion if someone is not from here and has, well, we're going on tour in 20 days, less than 20 days. European tour is not coming to Sweden, but any other place on the mainland of the European continent, pretty much we're gonna be there. With Dynasty, they're Swedish, so it's not here. I'm here today, so that's the best we could do. But next time we'll be playing in Sweden as well. Hopefully, we've been only once. I think we played in at the Sabaton Open Air Festival in Falun, and that's it. But so if anyone happens to be around these places, just let me know. So that's it. Thanks a lot. Yeah, questions? Just one T-shirt, one shirt. Sorry? What do you mean? Sorry, I didn't understand. What's your favorite mode? Oh, you mean the genre? What? Okay. Sorry. Yeah. But Pluto is not a planet. I didn't decide for that, so it's not my choice. Yeah, I don't know. It's discrimination, but it's not my fault. Yeah, sorry. Oh, thanks a lot. My favorite Nanowar song. It's a question you shouldn't ask, but because there's too many of them. I don't know. I can tell you my favorite underrated Nanowar song probably is The Quest for Carrefour. Yeah. But it's because it's not so known as others, but I think it should be more. Yeah. Oh, the Spanish one. Oh.
So I can just add in
Thank you. Yeah. So I don't know if there's other questions or it's well, okay. Thanks a lot.